No, great, Mark. Welcome.
Yeah, thank you. Thanks.
Thanks, folks.
Okay, so we'll move on to our guest speaker. So I'd want to introduce Francesco again. He'll be introducing the Kilter systems to this group. So I'll hand it over to you, Francesco, to introduce yourself and start your presentation.
Yes, thank you. Just a question. How much time do I have? Because I don't remember exactly. So I
We
can.
usually give about 25-30 minutes for the presentation itself. The meeting goes to 10 a.m. Our time in
Yeah,
Asian
perfect.
Canada. And then we give some Q&A time after that too. So you have a good chunk of time to use.
Yeah, perfect. Okay. Thank you very much. So
Thanks.
I'm Francesco. I work for Kilter since a couple of years. I've been doing different things in the company since the company it's let's say it's still a startup, but now it's ramping up, and we are really scaling up the production and our presence in Europe at least. We hired I think more than 20 people since I started 2 years ago, and we developed this robot that I'm going to present you, which is meant to be used in vegetable farming. Mainly now our focus is in vegetable farming, herbs and small vegetables. And yeah, that's the purpose of the robot is to kill the weeds. So just to spray what we don't want in the field. So let me share my screen to start. So here we are. Can you see?
Yep, it's good.
Yeah. Okay. So let's see if it's working. Yes. So yeah, as I mentioned to you, we are in Norway. We are established since 2021, but the idea behind the company is it's older. It's been since 20 years that the University of Oslo was working on a solution to get rid of the weeds in the field with the lowest amount of input in terms of money, in terms of herbicide, in terms of everything. They have been testing all the different technology and solutions that were present in the market at that time and during these years. So laser, warm water, steam, fire, electricity, all the sort of spraying equipment. And they landed in a prototype that became the robot that we now produce, which is using a technology that it's different from the regular nozzle because it's not spraying the mixture of herbicide and water, but it's releasing single droplets. I will go a bit deeper on this during the presentation. As now we are present in Europe and mainly in the Scandinavian countries, so Norway, Sweden, a bit in Denmark now, and also Germany, Netherlands. So we are expanding from Norway to the south, and we have also some robots in Australia. And at the moment, we can operate on 14 different crops, but we are developing 10 models more to be able to work on more crops, and we are always in the process of developing new crop. Yeah, I go on with the presentation, but if you have any questions, you can interrupt me. Feel free to ask, and yeah, I will be happy to reply during the presentation, or if you have questions at the end, even at the end is fine for me.
So you tried
Yeah.
steam and hot water.
Yes.
How did you like those? Because that's an interesting concept.
Yes, I was not present in that project because yeah, it's 20 years old or it was started in 20 years ago in the University of Oslo. But yeah, they tested the use of warm source, so water or steam on the weeds, and the result was not sufficiently nice in terms of the percentage of killed weeds, because the weeds must be quite small to be
Sure.
killed from the weed. and also the amount of energy you have to use is quite high because you need a
Okay.
lot of water, and also to produce steam is not something easy in the field. Yeah, so yeah, it was an idea. It works in a part, and for sure it's nice because you don't use chemicals. But on the side of the results and the energy consumption is quite bad.
Yeah, I've had people mention the concept before, but I hadn't heard of anybody trying it
Yeah,
practically. So
I think
thanks for sharing that.
yeah. Thank you for the question. I think in Europe it's a bit more tested because we cannot use any sort of chemicals in organic farming. Even the pelargonic acid is not allowed. So if you don't have any other solution, then you test whatever you can. But yeah, in Canada or Australia or the US, you can use pelargonic acid even in organic farming. So I think that's a way better solution. So going on, why we know probably what's the problem. So the society is demanding less spraying. The politicians are following this request, especially in Europe. We are looking at the chemicals reduction day after day, which is of course a good thing for the environment. But we need to give some new weapon for the control of the weeds in the field to the farmer. And another problem that we are facing in Europe, it's the lack of manual labor. So many farms, especially in the herbs production, are using the manual weeding, but nowadays they are facing really some difficulties in finding people to do that job. But coming to the technology itself, this is the robot we are producing, AX1. It's a spray technology unit, so it's even on the low side is compared to a normal sprayer, but it's based on artificial intelligence, and it works with this patented technology, which is it sits in this I don't know if can you see my mouse if I point it, or probably not. Yeah, anyway, the droning in the middle is the core technology of the spraying unit. So you have the camera on the top, and on the bottom side you have a line of nozzle, and each unit has 42 nozzle. But when I say nozzle, we have to think about a specific type of nozzle we produce, which is releasing single droplets. Here on the left, you can see on a plastic plant the result. So you can see the small droplets on the leaves, and they are spaced in between 6 millimeters between each other, and every single droplet is released individually. So how it works in practice? This is a photo from one of the module. The machine can be built with 5 or 6 modules. That's what a module is looking in the ground. So it takes a picture, and then the AI is detecting what is the background, of course, what are the weeds, and what is the crop. So in this case, we are spraying carrots, and you can see in green the row of carrots. All the other plants are weeds. After the detection, the robot is deciding where to place the droplets. So it overlaps this other mask on the image, and you can see a lot of red dots, and there are the place where all the droplets will be released on the weeds. And around the crop, you have this square, which is the safety zone. So both the safety zone and the spray area can be adjusted in the app while you are driving the robot, or while you are setting up the robot for the autonomous driving. Because sometimes you can have a wind, or you can have some specific condition that requires a bit more, it requires you to be a bit more careful, and then you can expand the safety zone around the crop to be sure that you are not hitting the crop. Or if you are using a selective herbicide, for instance, you can reduce completely the safety zone and make the spraying area as big as possible. Here in this photo, you can see on the top you have carrot, which has a weed very close to it. And as you can see, part of the weed is covered from the safety zone, and that part will not be sprayed. And this is the result in real life. So you have the row of carrots, and in the middle a lot of weeds. Even when you have weeds very close to the plant, you can see that there are droplets around, and yeah, you know that this plant will be sprayed, or it has been sprayed. A little overview of the machine. It's a very compact machine. It's even a very light equipment. It's less than 300 kilos. You have the control unit on the top, which is where all the computer and all the AI is running. On the left side, you have a generator, because the robot is running on 2 electric motors, but we don't have battery to make it light. So we built the robot with a generator running on gasoline, which is creating the energy for the engine. And that's also a solution that the farmer are enjoying, because it's way easier to bring 5 liters of gasoline in the field instead of recharging the robot if it's the battery are empty. And on the right side and under the control unit, you have the tank and all the liquid system. So the pump and all the valve to circulate the liquid. Oh, I hear you very low.
They were just off mute. I muted them. You can continue.
Okay. Yeah. That's the backside. So you have the boom, which can be lifted. So you have the boom actuator that can be lifted or reduce the height of the boom with the spray units. This is a model with 5 spray units, but as I said before, can be built with 6 units. So coming to the side, we build the machine with different configuration, 5 and 6 spray module. And here on the bottom, you have the possible configuration. So the wheels, center to center, can be from 1.55 meters to 2 meters.
I see Anne Michelle has her hand up. Did you want to take her
Yes.
question now? Anne,
Okay.
Michelle, you can go ahead.
Okay.
Yeah,
Hi, Francesco. I am Anne
Hi.
Michel. I'm from the Canadian government, and one of the questions that really current we have is, do the customers have a right to repair by themselves your robots?
Sorry, no, I haven't got the question.
I was asking you the question, do they have a right to repair by themselves the robots?
Right, repair.
We,
So, do you
because
mean like,
because in some instances, some of those machinery are not supposed to be touched by any typical mechanical person. They need to be very specific, an expert, otherwise the guarantee doesn't work, ta 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 ta.
Yeah.
And you are
Okay,
far,
no,
you are in Scandinavia, and if you think to sell in Canada, that's a decent distance.
yeah, of course. Now I got your question. Yes, of course, we are not working just by ourselves. We do direct sales and support just in Scandinavia, but we have partner in Europe and in Australia. So in Europe, we work with Kubota, and in Australia, we work with Croplands, which is present also in Canada, I
Okay,
think.
okay.
And
All right.
they are taking care of the support. We have also a second line of support here in Norway, because sometimes the robot can have some specific bugs or something that is not in the normal maintenance of the robot, or in the, let's say, the normal problems, and then we can support the support. But yeah, there is also
Okay.
for the spare part, we set up an agreement with some distributor, some partner in the country. Absolutely.
Okay. So you got me with Kubota. That's a good one. Thank you.
Yep. You're welcome. Thank you for the question. Yeah, now there are small details, transportation options. We have That's a problem to move the robot. It cannot drive in the street, so we have to move it from field to field. And we have built a normal vehicle hitch trailer, which can be moved around with a car or a truck, or the classic 3-point hitch carrier for using with a tractor. To move the robot, to use the robot, to connect and to check what's going on, to monitoring what the robot is doing in the field, and to see what's going on. Basically, we have an app, so you can connect to the robot with a phone. You have to be nearby the robot because it's connected with the Wi-Fi. And then from here you can control the robot either manually or start the autonomous operations. The autonomous operation, they have to be set up in another system. So you have to do it at the office before, and then with the Kilter Remote control on the phone, you can start the machine in autonomous operation. I have some photos from some tests and some farmers, just to show you the result we have yielded in these years. So that's, if I remember well, it's parsley root, this production, and was tested by Nibio, which is a company working in really straight contact with the University of Oslo. So here we have the first part of the photo, the bottom part. It's the field treated with the pre-emergency soil herbicide, so most likely glyphosate and pendimethalin. And on the top of the image, we have an area just treated with the pre-emergency soil herbicide and the robot. So it's 1+2. And on the bottom, you have the drone footage to have even a better overview. So you can see where there is just the red F, it's where the robot hasn't driven, and where is F plus R, it's where we have a draw also with the robot. But here, even better from our customers, this is on carrots. You can see on the left side the farmer practice. So what has been done in the years before AX1, and on the right side you can see the carrot way cleaner. That's the side where the robots was operating, and was operating with a non-selective herbicide. I believe that case was with glyphosate, because in Germany you can ask for approval in specific condition to use a glyphosate in between the rows and with the crop in the field, like with the crop, not before the emergency of the crop. Another example here, again in Germany, it's some parsley, and here on the left again you have the farmer practice, what was done before. And on the right side, you have the field treated with the robot with the X1. You can see some weeds on the right side, but that's just the weeds that sits on the wheel tracks. Because one of the limitations of the robot at the moment it's that it cannot spray in the wheel tracks. And it's not just a decision; it's a technical problem, which it seems easy, but it's not. So I can go deep if someone is interested, but it's something that we are working on, but it's not an easy fix. And here again, I have some salad on the side. You can see this is a sort of chamomilla. I don't remember the name in English, but yeah, on salad. So even if it's a very thin leaf, it has been hidden by the robot, and it's slowly dying. On the right side, I have a small video. That is a parsley field. And in this case, it's the same farmer as the photo before for parsley. In this case, they have skipped completely the soil herbicide. So they have treated this field of parsley only with the robot. And they were really, really happy about the result. You can see a lot of weeds completely dead in the middle of the row, and the row of parsley is quite clean. Yeah, that's another short video. you can it's speed up. It's not the normal speed, but you can see the robot running, and on the right side you will see in a moment a group of people coming back from lunch. So they were having the break while the robot was still working, and when they come back right now, you can see the speed. The robot is way faster than this group of 7-8 people, because that's something that often is a question: how fast can the robot go, and compared to human labor. So the robot can cover around 1 hectare in 3 hours, but you have to consider that it can drive 24 hours, even during the night and on weekends, and yeah, whenever. And also another point for big farmers, especially, is that one person can operate 5-10 robots without any big issue, because he needs just to bring the robot to the field, start the robot, and then go on with the next one. So in terms of manual labor, it's reducing a lot the number of people that the farmer needs.
Francesco, what's the
Yeah.
pricing model for this? Are you leasing these to customers? Do they purchase these themselves? How does it work?
No, at the moment we do sales, direct sales, so we don't do the lease. I can give you the price for Europe, because of course it can be different next year. It can be different in another market, but in Europe at the moment we are selling one machine for 130,000 euro. So compared to a laser machine or compared to other robots, it's quite cheap. I understand it's quite amount of money anyways, but compared to the competitors, we are quite low in the pricing. I don't know if you get this impression or not, but it's nice to have your
It's
feedback as well.
like the cost of 2 workers, right? Almost.
Yeah. So a small list of benefit of use, herbicide use. Of course, the herbicides use is reduced. Here I wrote 95, but from the experience from our customer, from the data we collected from our customer in 2025, we saw that the average of the reduction was 96.6, so even more. And the ROI, it's around. It depends, of course, on the size of the farm, on the crop that the farmer has, and a lot of factor. But we can see that in 1.5 year, 2 years, the robot is completely repaid. Another very interesting data is from the third line. So the increase of the crop quality. That was from the field trial I showed you before on the root parsley. And in that case, we saw an increase in the yield of 48%, which is really a big number. I will never say to a farmer that we we will achieve this number anyways. But what we saw is that, especially with vegetables and herbs, when you avoid using the soil herbicide, you reduce the phytotoxicity. So the plant it's less stressed. It can grow quicker and better. And you have in root parsley, another data that is really relevant for the harvest is the uniformity of the roots. So if the site is similar, the yield is way more valuable, because it's easier to to divide it and to sell it. So the uniformity of the plants were also better. And also, when we use selective herbicide, so we can spray the crop. The crop is, in any case, receiving a little bit of stress, so that if phytotoxicity is happening also in that case. And yeah, we lose some days of production because the plant has to recover from the stress, or we can have some variation in the growing. So maybe some plants are recovering quite a bit faster, and then we have not good uniformity. Other points is that in case of selective herbicide, we can, with our robot, the X1, we can spray the full legal dosage. In some cases, we have some selective herbicide that are selective, but we have to use a low dosage. Like we have, I don't know, maybe between 1 and 3 liters per hectare. And then we know that we have to use maybe 1.5 because otherwise the crop it's gonna be stressed too much. But in this case, the crop is not affected by the spraying, so we can easily use 3 liters. Of course, the operational cost of weeding it's reduced, especially versus the manual weeding. It's incomparable. And yeah, again, the herbicide residue on the crop also it's almost zero. It happened just once in one field at one farmer in Germany. It happened that he was using the robot with glyphosate, and after the spraying, it was raining quite a lot for a couple of days. And some sample of lettuce that he has in the field were showing small residue of glyphosate. But that was, I would say, it's really an edge case. Like so, the salad was not sprayed because otherwise we will not be harvested, but was probably getting some of the glyphosate through the soil, or I don't know exactly how. The robot it's working absolutely well, as you could see, but it's really important to use it in the right way and in the right farm with the right crop. So the matchmaking between the farm and the X1, it's really the first step that we want to underline every time we speak with someone. So we have to go through these 5 points, and now I'm going a little bit deeper in each of them to be sure that the robot will be a success. So first of all, we need to work with a crop that we support, because when you start the robot, when you start the operation, you need to select which crop you are going to spray, because for each crop we have different models. It's not just one model trained on with the AI. It's one for carrot, one for parsnip, one for rocket salad. And then, yeah, the robot is behaving in a different way. Because, for example, if you have, I don't know, a field, let's say an example, you have rocket salad, but the year before in that field you had carrots, and there are some carrots growing also the year after, you want to kill the carrots. So if you use a general model, you will save the carrots. But if you use the rocket salad model, only the rocket salad will be saved, and the old carrot will be sprayed. I don't know if I explained myself well in this example. Yeah, hopefully, yes. And at this link, also, you will get the presentation after, I think. At this link, you can find also the crops that are under development, the 10 I mentioned before. So and we continuously update the page, so you will get all the new crops that are coming. Yeah, coming back to the track wheels, the field profiles that we can support are just the flat or the beds, and that's because we need to have a flat field under the spray area. So in the case of bed, the top of the bed is flat, and we will spray only the bed, not the slopes in the side of the bed, not the edges, and then not the track wheels. Unfortunately, at the moment, we cannot operate on ridges. And of course, when we saw some very messy field, like the example here on the right bottom corner, we cannot operate in this kind of field because of the placement of the droplet. The robot is not it's not able to have let's say a 3D map of the soil. So it has to be flat to place the droplet in the right place, in the right position. And since the precision is 6 millimeters, it is really relevant to be accurate. Connectivity, it's another very big point. So the robot works with GPS RTK, with internet correction, so the N-trip, and he needs to be connected. Cannot work without GPS connection. when we operate in autonomous, of course. The tracks that the robots follow are obtained from the previous operation. So if you had a tractor with the GPS, you can collect the data from the tractor while doing the bed forming or while you are sowing. And then through the cloud platform we use, you can upload the GPS tracks to the robot. So yeah, the only GPS system we support is the RTK N-Trip, so with the internet correction, because that's the most accurate. It's 2 centimeter accuracy, and that's allowed the robot to drive smoothly, even on the beds, and achieve the precision we need. Another point to mention is the application. So when to use the robot, because for my experience, I was advisor before, so I always try to make comparison on what the farmer I used to do. Usually, when you have to spray to control weeds in a crop, you are looking for the stage of the crop that you need to spray. So you wait 2, 3, 4 leaves, it depends, and then you can apply the herbicide because you know that the crop is gonna support the stress and go on in the best way. In this case, with X1, we have to shift a bit our mindset, because we don't have to look at the crop, because the crop is not affected by the spraying. We just need to focus on the weeds.
Yeah, Francesco, I have another question. It's still on
Yes,
Michelle
please.
from Guinean government, agriculture. So this idea to have a flat soil in order for your robot to be performant.
Yes.
So, in Europe, you have the same issue that we have here. You have this soil drainage when you have intense rain. So, does it mean the farmers have to do some specific operation to make sure that the flatness stay the same, or do you require that, or is it still, even if the soil is not perfect, is it still doable?
Yeah, it doesn't need to be perfect, because we know in farming it's not possible to achieve perfection. But the idea is to be as flat as possible. We can operate on hills, so even if it's a bit hilly, we can operate until 7% of slopes. And in case of drainage or some ditches to get rid of the extra water, we have some example in Netherlands, for example, and they have these ditches, but they have also the GPS tracks for the ditches, so we can overlap the ditches and the track for the operations, so we know where the ditches are, because the robot can drive through the ditch, because usually it's not very deep, but it has
Okay.
to lift the boom to avoid having problem to the camera system. So it has to do some minor switch while driving to the ditches.
Okay. And
So
if I
yeah.
remember well, for example, last year
Mhm.
in France, it rained for 3 weeks in a row. So does it mean that in kind of situation, the robot cannot be operated?
Yeah, rain. Unfortunately, it's the main issue when you have to apply herbicide. In any case,
Yeah.
it's not possible to spray. The good point of this kind of equipment is that it's very light. So when the rain stop, the first second the plants are dry enough, you can drive with the robot in the field, because
Okay.
it's like really almost a footstep of a man, because it's
Okay.
280 kilos. Yeah,
Okay. Thank you.
thank you. Yeah, so again, coming back to the application, what we saw from the experience of our farmers, especially if we use the pelargonic acid, which is less effective than glyphosate, it's good to enter in the field as soon as possible. So when the weeds are quite small, 2, 3 true leaves is the best window, because they are still very small to be killed with the glyphosate, with the pelargonic acid, but it's quite easy for the model to detect them. Usually the model can detect the weeds also when are cotyledonal stage, so really, really small. The only issue when the weeds are very small, it's that they can, if they are smaller than 6 millimeters, they can fall in between two droplets. So yeah, they might be detected but not hidden, because yeah, they are too small. Again, the suggestion we give, especially for pelargonic acid, is to drive the robot a couple of times if there is time. So one time very early in the season to get rid of the weed, and a second time a bit later, like 2, 3 weeks later. It depends a bit on the season, how the weeds are growing, and yeah. But if it's possible and if it's doable for the farmer to drive a couple of times, yeah, that's the best result. Since the machine, it's not expensive in the operation, because it consumes around 1 liter of gasoline per hour, and it's autonomous, so no one has to drive it. Yeah, it's really beneficial to drive it twice if there is the time. The only cost is the time. Last point is the use of herbicide. So the machine has a particular nozzle. They are very thin, like very, very small, with very like very thin filter. So not all the herbicide can be used. What we saw is that suspensions and encapsulates are often creating problems, because of the filter clogging, or the agitation is not enough to get all the herbicide diluted in the water in the tank. Yeah, but when it comes to water soluble or emulsions, usually they are good. To be sure that we achieve the best operational workflow, the ideal is to use very clean water, because the quality of the water is affecting the chemicals in a very big way. And then, yeah, you can have a bigger problem if the quality of the water, the quality means the pH is not balanced, or the amount of salt that dissolved in the water, so the heaviness of the water, or if you have iron, this kind of details are really creating problems to the machine. So some farmers that are working in an area with poor quality of the water are buying some like pure H2O. It's more expensive, of course, than use the water from the river. But since we are spraying really a small amount of area compared to the full field, yeah, the consumption is not that much, and it's really worth it to keep the machine in the best shape and condition. So that was it for me. I hope you enjoyed, and I'm very open to questions and comments or whatever.
Perfect. Thank you. I see we already have somebody with their hand raised. Cesar, if you want to go ahead.
Yeah, great presentation, Francesco. Thank you for
Thank
accepting
you.
the invitation. I'm very excited about this technology. So, 2 questions, and I already asked you this, but maybe it's good for you to answer for the whole audience.
Yes.
When can we expect to see one of these here in Canada? And that's number one. And number two is, this is different than any spray technology that, in fact, it's not a spray, any water distribution technology that I've seen for herbicide. Do you find that because the coverage is probably different than that what small droplets will give you, that weed control is equally as effective, more effective, same, or less?
Yeah, I start from the second question. Of course, that's a very nice point you bring up. So for years, all the spraying equipment tried to create the smallest droplets possible in order to cover the full area of the leaf. and we are going on the opposite direction. So we create big droplets. Yes, that's affecting the quality of the coverage of the leaf. But we always suggest to use some wetting chemicals, so to help the water to spread on the leaf. And especially if you use glyphosate, you don't really need to have a full coverage of the leaf. Like you saw the result in the photo I showed you. The plants are dying quite quick if you use non-selective herbicide. But that's a good point, and it has to be checked. But again, since you are using not much, you are not spraying much area, you can use full dosage of the herbicide, and then you can achieve a better results. But yeah, I don't see it as an issue. And the third question is more an issue. So I don't have an answer, unfortunately. I hope we will get to the other side of the ocean soon. But yeah, at the moment we have this nice problem to not being able to build enough robots to our customer and to the people that are asking for the robots in the country where we are already present. So we are trying to produce more. We plan to produce way more next year. But yeah, I cannot promise anything.
All right, thanks. Richard, you have your hand up next.
Yep, thanks. For your herbicide, are you using two separate tanks, one for water, one for herbicide and impregnating, or is it a single tank with a tank mix? And then along with that, is it how many acres can you do on a mix before you need intervention from the operator? Thanks.
Yeah, that's a very good question. So the tank, it's divided in three tanks. So you have one tank with the mixture. So you have both water and herbicide. And then you have two small tanks for with clean water. One it's for safety reasons. So if you get the mixture in your hand, or you get you can wash your hand or your eyes and everything. The other tank, it helps to clean the system. So it's again clean water, and it has used just at the end of the treatment to clean the system. So the big tank, it's the mixture of herbicide and water, and which is 55 liters. With 55 liters, it depends a bit it depends completely on the weed pressure. Let's say in the worst scenario, so with the weed covering the whole area, so 100% of spraying, we use 278 liters per hectare. But that's really a bad scenario. So usually we spray something around 5% of the area. And then one reservoir can last for 2, 3, 4, 5 hectares.
Thanks.
Is there any other, is there any other questions for Francesco?
I have one really quick one.
Go ahead.
What do you think the payback period might be on something like that, on a robot like this?
That's very, very difficult to estimate. We have created a small Excel sheet to try to calculate on your own, because it depends on a lot of factor, even the cost of the labor in your country and the gasoline cost and everything. But more or less what we saw from our customer is in between 1.5 and 2 years.
Okay, cool. So that's great.
It's really a number that can vary a lot. It depends on many factors.
Awesome. Thank you.
Okay. Caesar, you have one more question?
Yeah, just to add up to that ROI question. I haven't done any numbers on this machine, obviously, but for what I've seen on the other ones, it's quite fast. They pay back. Because what Francesco mentioned, and obviously that's anecdotal. He said 45% yield increase. That's an extreme case, but you really need a small percentage on your yield increase to justify the price of these machines. When you multiply by the yield per hectare and the additional revenue, it's quite significant. And not saying that you're always going to get that, but in certain situations where the crop may be a little stressed, the fact that you're not spraying any chemicals on top and it's more like directed, I think it can be a hidden benefit that is not always considered. It's not just on in terms of saving chemicals or even labor.
Yeah, absolutely. Yeah, we have the best example we can give in terms of ROI. It's we have one customer in Germany, which is our best customer. I think they grow on almost 2,000 hectares just herbs, and that's the best fit for the machine probably. And they bought the first robot. I think it was March last year. They were a bit skeptical. Of course, it's a new machine. They have to test to see how it goes and yeah, to check. They are testing all the robots, all the laser machine, everything. And they bought the second machine end of May, the third machine in June, and this year they bought three more. So they have six now because they saw the benefit for them is unbelievable. Or even in the packing, because they do also the packing of the herbs. They said that the sorting of the weeds is way faster because there are less. So they are even saving time in the packing, which is a huge amount of people involved. So probably a lot of saving.
Great. I think we'll cut it off there for questions. So thank you again for coming onto our call and introducing us to the Kilter system as well. If anybody has any follow-up questions, feel free to reach out directly to Francesco as well. I'm sure he'd be happy to answer those questions.
Absolutely.
I did drop the crop list in the chat as well. So if people are curious to see what crops that you currently offer and which ones you're working on, it's in the chat as well. Thank you for coming on and introducing us. For the next couple of minutes, I just have a couple updates for project updates. We have posted the project coordinator role that Dan Woods was previously in. So if you know of anybody who might be a good fit or is looking for entry to the agriculture project management, feel free to reach out to me or share the job description. It's on the AgRobotics website and also on our LinkedIn as well. So happy to connect with people to talk more about that. And then I just wanted to give a moment for one of our new members, John Mann from Grand Farm. They had a pretty big announcement this week with some funding in the US. John, did you want to maybe give a brief overview of that?
Sure. Hi, everyone. My name is John Mann. I'm the Startup and Investor Program Manager at Grand Farm in Fargo, North Dakota. We're an ecosystem builder working with startups, corporations, university, government. We have about a 590-acre farm where we test different technologies. This week, we announced a partnership with USDA and land-grant universities to basically build out a program testing and validating technology for farmers around the country. This is going to be year one, so it's going to be a lot of learning, pretty much pilot projects. And the focus is around weed destruction and weed scouting. So primarily looking for robotics platforms, tractor implements that are capable of identifying and destroying weeds, or drone-based systems, UTV mounted systems, wherever it might be, that can scout and just identify weeds. Mostly focused in soybean and sugar beet. North Dakota is most likely going to be the two crops. And then for a second site, not set yet, but it could be onion. That's still being figured out right now, but soybean and sugar beet will be primary focus in North Dakota. So if there are any folks on the call who are looking to get involved in the project, you can reach out to me and I'll drop my email in the chat.
Yes, I was just going to say, Kate just asked for you to drop your contact information in the chat. So I'm guessing she's one of them that would like to reach out to learn more about it.
What do you need, John? I saw the announcement. It's very exciting. Is there any specific needs that are keeping you up at night right now, other than you've got to execute?
Yeah, I mean, we're USDA is focusing on kind of design of the plots, which I think ends up being a pretty interesting conversation as we look at different robotic systems that are being enabled, implements, how they're used differently. Some of them are going to be entering the field pretty early in the season, others maybe not, and it's pretty broad. So this year's a pilot year. We're going to learn a lot. I'm thinking it's mostly going to be mechanical, potentially laser termination will be a focus. Spraying is a possibility, but right now it's pretty small plot focused, and a lot of the implements we're looking at are pretty large. So it's all being put together very, very quickly. So right now, really, we just want to make sure that we're being inclusive of all companies that are out there. It's primarily US focused. Not saying we're going to exclude any international companies, and I recognize I'm on a Canadian call, but chances are we're going to want to focus on companies that have strong presence in the US, or tend to have strong presence in the US. But anyone who's kind of tackling these challenges, I'd love to engage and hopefully get you involved this year, and if not, next year.
Great, thanks. Oh wait, well, I think we'll end the call there. So thanks, John, for sharing that. And congrats on that announcement. We will reconvene next Friday. We have a speaker from Verdant who will be speaking about their robotic solution as well. So stay tuned for more information that will come out next week on that one. Have a great weekend, everybody.